Personal finance practice problem using Excel. What if we saved our $5 a day coffee habit? Prepare to get financially fit by practicing personal finance. Now, before we go into this in much depth, I do want to point out something that many people are probably thinking, so we can address that first. Many people are probably thinking, I know what would happen if I cut my $5 a day coffee habit. I'd fall asleep at work, I'd get fired, I wouldn't have any money, then I'd have to spend all my time in the coffee shop because that's the only place I get decent Wi-Fi, and if I didn't buy any coffee, then the baristas will all get mad at me because I'm sitting there using the Wi-Fi and not buying any coffee and so on. So if the not buying coffee, in other words, would cause you a problem, then you don't have to do this. But the general idea would be that if you can cut out a little bit of money on a daily basis and save it, it could kind of go a long way. So here we are in our Excel worksheet. We have the practice tab on down below, and then the example tab in essence being an answer key. We got the information on the left-hand side. We're going to populate that into the blue area on the right-hand side. So we're going to imagine we have a cost per day of the $5. We're going to imagine that we save that $5 in some way, shape, or form, possibly by coffee, possibly in some other area. So then we're going to say that how much would that be on a yearly basis if we were to add that up, those days, to a yearly basis. I'm going to use a 360-day year, which is often done in finance because it kind of evens out the months, meaning it's nice to be able to assume 30-day months, so it's all nice and even. 12 times 30 would be the 360, as opposed to the more close to accurate number in terms of actual days, which would be around 365. So I'm going to take then 5 times 360, that would be $1,800 a year. And then let's assume just on a yearly basis, and again, you could do this on a daily basis, but let's say we take that $5 and spend it on a yearly basis of the $1,800 and put it into a savings account. What would that do if we could save that over 10 years if we're assuming compounding yearly at 8% in whatever we're investing in, whether that be stocks, a savings account, or so on, in terms of our average investment returns at the 8%. So this would be a future value of an annuity type of calculation. Let's first do it by just doing a running balance type of calculation, just listing out the number of years and assuming that we're depositing or making another deposit yearly of the $1,800. Now this is an annuity calculation, so we're not going to start at 0 usually. We start at the end of each period, which is going to start at period 1. So period 1, period 2, and so on. Let's copy that on down with the autofill. I'm going to do this a little bit quicker because we have seen this in the past, or similar problems, just as this different kind of scenarios to take a look at here. We're going to go to the Home tab up top, Alignment, and center this. Now, the first payment's going to happen in year 1 in our assumed annuity, and we're going to do it on a yearly basis. We're going to assume of that $1,800. Now, note that you could do this. You could think about, well, I'll save that money on a weekly basis or a monthly basis, and so on. You can adjust your calculations accordingly. We're going to keep to the yearly basis here. We might do that in a future presentation to look at the compounding that could happen or the annuity that could happen if you're putting more money in on a basis other than basically a yearly basis. So then we're going to have the investment, which is going to be equal to the 1,800 starting point. Then the increase that we're going to have from the investment, which could be from stocks, could be interest in a savings account, and so on, would be equal to the 1,800 times, we're going to pick up the 8%. I'm going to make that an absolute reference because we're outside the table. I would like to copy this cell down. I'm going to do that by selecting F4 on the keyboard, putting a $ before the B and the 6. I'm going to select Tab this time, which will take me right to the tab to the right, instead of Enter, which will take me to the tab below it. Then we're going to pick up the payment, which is going to be that $1,800. That, once again, is something outside the table. I want to make it an absolute reference, selecting F4 on the keyboard, $ before the B and 4. I'm going to say Tab now, taking it to the cell to the right. Then I'm going to say equals the one above it, plus the SUM, Shift 9, left arrow, and then holding down Shift, left again, closing up the brackets, Shift 0, and Enter. Now I'm going to select those 3 cells and autofill it down, putting our cursor on the fill handle, dragging it down, and we can see the increase resulting that we'd be saving on earning on a yearly basis. We would be having $26,076. The payments that we put in place, you can select this column and see the sum calculation, $18,000 over the 10 years, and the increase, meaning the earnings and interest or whatever format we have, $8,000 76. Let's do that same thing with an annuity calculation now. So let's hide some cells from C onto G. Let's go from C to G, right click and hide those cells. We're going to do this with an annuity calculation. Once again, I'm going to do this a little bit faster. Since we've done these a few times, I'm going to say negative this time instead of equals, which is a little bit faster, and we'll flip the sign so that we do not have to basically put, go back in and put a negative number. It'll then result in a positive end result. And notice I could still type in future value here, and it still gives us our functions down here, just like if I typed equals. So if you want to flip the sign easily, instead of putting a negative, instead of putting equals, you could just start with negative and then type your function like you normally would. Shift 9, the rate is going to be equal to this 8%, comma, the number of periods is going to be 10 in this case, comma, and then the payment is going to be, because it is an annuity, we will be using the payment, that 1,800, and enter. So there we got the 26.75 again with the 81 cents. We could do that same thing with the calculations for a table and the calculations for the mathematical formulas. Two ways you probably wouldn't be doing this so much in practice, but can do oftentimes for test questions. So we're going to put our cursor on H, drag to J, let go, right click that selected area and hide. We're going to do this formula now, future value of an annuity, which is the payment, which is going to be the 1,800 times 1 plus R, which is going to be the 8%, to the number of periods, which is 10, and then minus 1 divided by R, 8%, practicing putting this into a table format, a format you might see in a tax return or similar to a financial statement format. We're going to put the payment up top, outer column, 1,008. Then we're going to have the numerator. I'm just going to call this the numerator, which is going to be this whole thing, which I'm going to put in the inner column or inside and indicate that with the colon up top. I'm going to bring that inside here. This is going to be equal to, let's say, 1. Right here, then I'm picking up the rate, which is going to be equal to the 8%, making that a percent by going to the Home tab number, percentizing it, underlining it, Home tab font group, and underline. That's going to give us a subtotal. We're going to call it subtotal. Summing this up using the trusty sum function, SUM, Shift 9, up arrow, holding down Shift up again. There. Let's make this a percent by going to the Home tab numbers and percentize it, 108%. We're going to take that to N now, which is going to be the number of periods, and that'll be N periods, which is going to be 10, equal to 10. Underlining that, we're going to go to the Home tab, font group, and underline. We don't really need the decimals here. Removing the decimals. Then we'll have another subtotal. So this is going to be a subtotal. And we're going to take this is equal to the 108%, Shift 6 or caret to the 10 periods. That's going to give us 2, but we're going to add some decimals going to the Home tab, number group, decimalizing it. And then, so that's going to be this whole piece right here. Then we're subtracting 1 from it. So I'm going to just say less 1. Underlining that by going to the Home tab, font group, and underline. And let's give us, that's going to be the numerator. Let's put that in the outer column. This is going to be equal to the 2.15, so on, minus 1. Let's make that a percent, or add decimals, I should say. Home tab, number group, decimalized. So there we have that. And then we got the denominator. So the denominator, so we got this whole thing here. Now we're going to take the denominator, which is simply R. Put that in the same column. That's going to be 8%, the rate. Making that a percent. Home tab, number group, percentize. And then font group and underline. And that'll give us, let's call this another subtotal. Putting that in the outer column. This being equal to the numerator divided by the denominator. Making that then a decimalized number, adding decimals. In other words, Home tab, number group, decimalized. And then font group and underline. And that'll finally get us to the future value of the annuity. Future value of the annuity, now multiplying these two components, the outer column, that being the 1,800 times the 14.48 and so on. We get about 26.76. Let's add some decimals. Home tab, number group, couple decimals. Let's do some indentations here, selecting these items and indent them. Home tab, alignment indent, and then we'll take the numerator, indent that again. We could do some spell check, see if I misspelled anything. Yeah, of course you did. Misspelled stuff. Okay, so there we have it. Now let's do it with the table. One more time with the table time. And this is going to be a payment. And the payment is simply going to be that $1,800, picking the amount from the table, making sure we got the proper table. This is the future value of an annuity table. And we're looking 8 and 10. 8 and 10. Here's the 8. Here's the 10. 14.487, 14.487, 14.487, 14.487. Add a couple decimals. Home tab, number, couple decimals. Underline it. Font group, underline. And there's our FV, future value, annuity. Multiplying that out equals the 1,800 times that 14.487. And so we're at the 2676.60, close to the 2675.81, not exact due to rounding. This being the actual number that would be on the table if they took it out more than 3 to 4 digits. This being where it is at if only taken out 3 to 4 digits, resulting in a slightly different number between the table and our other calculations. Let's go ahead and unhide our cells by going to the B to L column, let go, right click, unhide. So we're going to say if we save that money, we would be totally tired and our whole life would fall apart, but we would be able to save $26,076. All the baristas would hate us and give us mean looks in the coffee shop because we never buy anything, but we would save $26,076 and earn that over time if we saved it. And then we'd have the future value of the annuity, also 2675.81. If we calculate it with our function, we calculated it this way, 2675.81 with the formula, and then slightly different 2676.60 if we use the tables.